Section 4.5, Net Change Theorem. Okay, the idea here, right, is now we start talking about a little bit of application, right, for derivatives. So rather than us have us restate everything, the idea here, okay, is the definite integral, okay, of the rate of change of quantity f prime of x, okay, gives the total change or net change in that quantity. So the definite integral of the rate of change of, be helpful if I could write to where it was clear, quantity f prime of x So remember, if we have the integral from a to b f prime of x dx, that just equals f of b minus f of a. Congratulations on your guys' playoff win. Do you guys have now? They're not good, right? I was being slightly facetious.
How many times have you guys come on?
That's why I went out to go to college. I'm not 6'8". Yeah, I'm not saying. Well, I was like, I'm 6'4", but anytime I went to like a lot of combines or anything, I was always like 6'2.5". Yeah. You're so tall.
Wait, how did you guys do it?
Okay, so here's kind of the idea. This is going to be some word problems. This is going to be talking about rates of changes. These are very, very common when we're talking about particle motion, right? Because if we think about integration, integration is just the accumulation of stuff, right? So the idea here is that we could use this for particle motion, okay? And then we're going to have two different pieces that go with particle motion. One is going to be distance traveled. One of them is total displacement. Okay, the difference between distance traveled and total displacement, right? If I start here, okay, and I walk 10 feet this way, and then 5 feet backwards, and then another 10 feet, how far did I actually travel? 15 feet. What was my total displacement? Or so that's the displacement. What was my total distance? 25, right? Or 30?
No, it's 25.
Okay. You sure? It's 10, 5, then 10, 25, right?
Yeah.
Okay. All right. We're just going to jump into some examples. Okay, so we have a chemical. This is like a lot of writing, so I'm just going to shorthand a lot of this. Are we good with that? Okay, so we have a chemical, right, that's flowing into a tank, okay, at a rate of 180 plus 3t liters per minute, okay, where t, okay, is the time in minutes, And we're going to go 0 less than or equal to t less than or equal to 60. We want to find the amount of chemical that flows into the tank during the first 20 minutes. Okay, so all that we're going to do is set up our integral, right? So our integral is going to be what our lower and upper bound? 0 to 20. What is our equation? 180 plus 3t dt, right? We all have the skills to do this. Go team, go. Yes.
Wait, what's like in context of like this problem, what is the integral find?
And it finds the accumulation of the rate of change. So remember, we're trying to figure out how much chemical, right, flowed into the tank during the first 20 minutes. So, right, the integral is going to represent that accumulation of the rate of change. All right. Antiderivative of 180. 180t. What's the antiderivative of 3t? 3t squared over 2. And we are evaluating this from 0 to 20, correct? So 3,600 plus 600, right? There's the 20. What's the second part going to be? Zeros. Okay. What do we get? 4,200, right? So the thing that sometimes we struggle with, right, is making sure that we're interpreting this in context. So what does that 4,200 represent? So it is the amount of chemical that flows into the tank in the first 20 minutes is 4,200 liters. Does that make sense? The amount of chemical that flows into the tank in the first 20 minutes is 4,200 liters. Okay. Are we all good? All right, so here's kind of the idea. If we have this integral from a to b, right, of the v of t dt, this equals s of b minus s of a. What does v represent? Velocity. What does s represent? The position of a particle, right? Okay, the integral, the way that I have this written, is that going to represent our displacement or our total distance traveled? Just the displacement, right? What does this lack? It lacks the ability to see when the particle moves backwards, right? Graphically, what does this represent? Well, if I have anything negative, right? It's anything that's underneath the y-axis, correct? Yeah. Right? Displacement includes this portion here. Does that make sense? Yeah.
You make it absolute value.
Yeah, you're stealing my thunder, but yes. So for displacement, I leave it the way that it is. However, if we want to talk about the total distance traveled, right? What we would do, so this is displacement. If we want total distance traveled, we'd do the integral from a to b of the absolute value of v of t dt, right? And then this is going to give us what?
S of B plus S of A.
Well, yeah. So this gives us our total distance, but it doesn't give us s of b plus s of a, right? We still follow the fundamental theorem of calculus. What this does, okay, is we have this function up here, right? What it does is it keeps this part the same, and it keeps this part the same. What it does, though, is it takes this part that's underneath and makes it on top. Does that make sense? So the pink squiggly is the absolute value of V of t. Are you guys with me?
But it's still SB minus SA.
It will still end up being S of B minus SA. We will end up having to potentially break apart this integral for it to work. Okay. All righty. We good for an example? All right, so velocity of a particle, it's going to be in feet per second, okay? V of t equals t cubed minus 10t squared plus 29t minus 20. Okay, t is the time in seconds. Okay, velocity is in feet per second. Okay, I want to give you guys a second. I have two questions, okay? The first one is I want you to find the displacement. Okay, from 1 to 5. And then we'll start there. Go team, go. Do we agree, disagree? Need another minute to crunch the numbers?
Mr. Carroll, somewhat there.
Mr. Borland,
How would you feel if I put you in Boston?
how would I feel if you did what?
If I put you in Boston?
I don't think you could.
I don't think it could either, but I think that'd be.
Want to try?
You're not making the ball that. Wait, I could put you in a half Boston grab and Jackson could be the.
I still don't think you could.
I mean, getting you on the fourth class bar. You lock that ankle in.
Just don't think you could. Depending on the people, anywhere from
From like 1 to like.
we're talking like 5th graders, like a whole class.
Okay, but we're talking about getting one.
How come you used to be the only one?
You're getting one, okay.
It's required, you're gonna need some
What
help.
about big country development?
I don't know who the second person is, but I watched Big Country get pushed all fun around, so I'm not really concerned about that.
How about the entire branch?
You guys probably did.
That's what you across the branch.
Okay, questions on this? Okay, what should my label be? Just feet, right? Okay, so here's what this looks like graphically, right? 2, 3, oh no. Right, this is what this, I mean, this is obviously a poor drawing, okay? But this is what it looks like graphically. Looking at the graph of this, do we think it is going, that the total displacement is going to equal the distance traveled? No, because we have this piece that's negative right here, correct? Okay, so when we start talking about, well, how do we do the velocity, right? Okay, so if we want to find the total distance traveled, right, what we need is, well, we need the integral from 1 to 5 of the absolute value v of t dt. Do we agree with that? Now, things that we know about this function, okay, is that its factored form, okay, is t minus 1, t minus 4, t minus 5. Okay. So, anybody have any idea on how I can manipulate this integral to get it to be what we need it to be? Braden?
You can find which part is negative and then add the things.
Okay. So what's my first integral going to be? From 1 to 4 of t cubed minus 10t squared plus 29t minus 20 dt. Do we agree with that? What's the second integral going to be then? 4 to 5. What is it going, like, what is it going to be though? How do I reflect this over the x-axis? Put a negative out front, right? So times negative t cubed minus 10t squared plus 29t minus 20 dt. Are there questions on how we set this up?
No.
We okay? All right, take a couple minutes.
Are you out of Kleenexes?
Yeah. Guys, I've gone through at least 20 boxes. I am too broke for this. What's the obsession with this Boston grad?
The origin of the Boston crab, obviously.
Get some other class, gonna do it with the bug.
Oh, we go to college. She goes to a different college. Let's just say she goes to ASU.
And I think you asked the right kids, it will be done.
It's hypothetically, right?
No, well,
Yeah.
hypothetically.
not in the script.
I'm
I was just
this
asking
is
if you
that
wanted
I'm
to
not
offer.
I'm getting this from social. So, like, the dude, he goes to a different college. Let's just say he goes to like UCC.
This one has.
And his girlfriend goes to like Arizona.
Up syndrome, lap syndrome.
U of A, not even ASU.
No, not even, no.
Okay.
And she checks up on her. And she sees her location at a frat party.
Did you ever have Miss
And
As one does, but we live in Arizona.
right? And he just goes online and just sees that all the dudes put his girl in positive crack.
Jesus, dude. Okay, I'm done.
She graded for it.
Hey, they said full Nelson giving her a
Next time you know what you need.
I don't like her grade.
That test.
Oh, hey, I'm trying her. They put me in the positive crack.
How well I was doing.
Jesus.
To me, I just saw but with real web application.
Yes. Oh, what happened to your face?
Oh, maybe when I leaned up on the board.
Honestly, that's even better. I think.
Who did that?
Flow. You got a picture of it already, right? Your new name is Brandon Slowsley.
Who's Flo? I'm bad with names. Oh.
Okay.
Wait, I did it.
What?
Fractions are decimals.
I need a nap.
Hey, if you guys do decimals, how many decimal places do you need to go to? 3, right? Questions on this? Are we okay? Yes.
When did the A and B trigonometry, like, 'cause
We split this into 2 separate integrals. This part is this whole first one done. I didn't do the minus, I shorted it. I just used calculator.
so 45/4 is.
Is this whole piece, and 7/12 is this whole piece.
But don't you have to do 1 and 4? Or what?
Yeah, I did 4 minus 1 and got 45/4.
Oh.
Yeah,
How many did he give you?
a calculator.
4 Kelvin.
But also,
Get it right or wrong?
it's math. All right, we have 2 more examples. 2 more examples, and then we're done. Okay. Neglecting air resistance. Okay, the velocity of an object after it is dropped from a helicopter is V of t equals -32 t. Okay? I want you guys to find the displacement after 2 seconds. What?
Is it 0 to 2 or 1 to 2?
While
Yeah. Oh, yeah, because 1 to 2 motions after 0 to 2. Yeah, so it's 0 to 2.
You forgot your negative on the second inverse.
Hey, I already gave you like. I appreciate you trying to.
I love Butterfingers.
I'd say that in terms of candy, they're somewhere in the upper middle class of candies. Almond Joys are.
I also love Almond Joys.
I think Almond Joys is always the best chocolate bar. I'm not a big chocolate fan. I prefer like fruit candy. Because I feel like chocolate always tastes just like chocolate.
We're still those.
Hey, Carol.
All right.
Let's see what size this is.
Think I can't do it? Nothing says happy birthday like surprise. Avery, what's your question? Because they're giving you the velocity. You're trying to find the total distance traveled. What if I wanted you to find the displacement from 3 seconds to 7 seconds? Okay, questions on this? Are we all good? Straightforward? Okay, one more example. All right, so the rate of change of profit P with respect to the number of units sold, X, okay, is called the marginal profit. The marginal profit for a product is modeled by dP dx equals negative 0.0005x plus 12.2, where P is the profit in dollars. We want to find the change in profit when sales increase from 100 units to 200 units.
Yeah, felt really good.
What do you think? Who'd you see 2 years ago?
There's a guy on TikTok who only trains one side of his body. It's like this side's like all buff and the other side's super skinny. And I saw him
while ago, and he was normal, like he was skinny. He's not.
That's fair.
Yeah, that's what we'll get. So I don't think you have to separate this.
How is what? How's what?
How is that different from this place?
Well, in this case, none of it's negative.
Oh, so they're equal.
Yeah, so here's the idea, right, is I can enter this into my calculator, correct? On FRQs, if it's, they're still gonna wanna see probably this piece. I'll be real, like you won't get something like this on the FRQ, you'll get, if it's on the non-calculator portion, the expectation is you plug and chug and go, and it's not usually very terrible. Okay, don't forget, we have to interpret this in context. What did we find? So the increase in profit is $1,212.50 when you increase sales from 100 units to 200 units. Does that make sense? You guys?